Good evening, everyone. This is Alt Beer here, and we're gonna start the stream and talk about badge life. So this is our future badge design session. Doesn't look like any of the badge team are on yet, so I'll just go ahead and get started talking about our crowdfunding campaign. So we launched an Indiegogo campaign a couple of days ago. So if you're following this badge and wanted to guarantee that you are able to get one for DEF CON, then yeah, jump on Indiegogo and you can see we are, it looks like 43% funded right now. And we have a lot of info on there. And let's just take a look at, oops, there they are. The actual claimed. So yeah, we still have a lot of kits left. It looks like we only have about 12 of the fully assembled left. So yeah, if you're interested in getting one, you should jump on the Indiegogo campaign. And here is the link if you need a short link for that. That way you can easily find it. Although if you type future badge as a search on Indiegogo, it seems to pop up as the first one. So that is where you can go to get the badge. And it looks like we have someone from the badge teams on.
Hey, Al.
Hey, how's it going?
Good.
So I was just going to run through some quick updates and then we can discuss. So I was just updating about the Indiegogo campaign for anyone watching the stream that hasn't actually seen it yet. And then we have the prototype has been completed. I got the notice this morning that PCBWay finished the prototype and it has
Nice.
gone to DHL shipping. So we should have it Tuesday of next week, and then we'll have some real boards to play with and show off on the stream.
Sweet.
Yeah, so that is awesome. And then the actual PCB, I'm kind of holding off making any other changes to it for now until we get the prototype in next week. That way we can see what we need to fix. But I know one of the things that I need to do is to get an SAO connector, a little 2x3 connector up here. That way people can plug in their shitty add-ons onto the badge. And we might do a shitty add-on. It just depends on time. Running short on time for that. But yeah, we have all of this is what was sent to the prototype manufacturing. So we'll just kind of leave it frozen in this state until we know what changes need to be made. So yeah, that's the major updates. I think I also talked on the last stream about the GitHub. So yeah, the GitHub page is private right now, but we'll be looking to make that public probably in the next 2 to 3 weeks, and then people can look at all the code, the EDA, and stuff like that, and it'll be short enough time frame that no one's going to beat us to the punch manufacturing these things. And the reason I say that is because this is all open hardware design, open software. There's no licensing or anything like that associated with it. I think it uses a standard MIT license on here. So that is, I think, it for my updates for right now. I do have more components on order. We're still going to have to order more, but kind of waiting for the campaign to work out before we get to that point. So we have that, and yeah, so let's jump into talking about where you're at with the code, as far as what you were doing for CTF. And keep in mind we're on a live stream, so don't give away any secrets. But I know you were working on some things for that. So anything you can share as an update?
Yeah, so I've actually established a couple things, toying with several ideas. The key points would be I've got a web server working. I've also gotten Bluetooth working where we could do a combination of or look at one path. I'm looking at that. The key point was making sure that we had enough RAM
Hmm.
to run the board, but also run a web server. Regardless, at a minimum, the web server could serve for turning in your flags, right?
Right.
If we decide to reveal them on the board itself, that
What
way.
I was thinking for the flags, we will probably stand up like a public web server that will have the ability for people to type in their flags. And what I thought was we could have the web server that's local on the badge serve up a QR code to the real
Mhm.
web server that will let them put their flag information
Yeah, that's fair.
in.
That'd make it better, so that I think it'll make it a little more difficult to get around it, right?
Yeah, and it also allows us to do a status board so that we can show like where the rankings are, who's
Statistics.
captured what flags, that type of thing, right?
That's a cool idea. Yeah, I like that.
Yeah. Yeah, now 0 Day All Day, we talked yesterday, and he wants to get with you because he has a lot of ideas for the different vulnerabilities that can be introduced as flags to capture. So, and he also had some ideas on how to minimize the memory usage of the web server and whatever other components are needed for the flags.
Yeah, I haven't seen him yet, so
Okay.
we'll see when I connect with him.
Yeah, he's on Discord, so you should be able to ping him on there and maybe get a hold of him that way.
Yeah, I have. We'll
Okay,
see.
perfect.
I didn't think he'd turn around that fast, but
Yeah,
and he hasn't, so that's cool.
not a problem. So we have the CTF is in progress. One of the things that I need to start working on is all of this blank space in here. I don't like that. It's all going to be artwork that fills in here. And so I'm thinking about like some cool background patterns and some like street scenes or all kinds of little things that I could put in the background. But then that's where I'll try to hide some of the crypto challenge cryptograms. So I'll hide it like in the background images. So that'll be the next up for what I'm doing on the art for that. So I think
That's
that'll
cool.
work out good. Yep,
Yeah.
cool. And then I don't think we stepped through the actual PCB layout. Did you want to have me step through that so you could take a look at what's what?
And I've looked through it, but yeah, I think for everybody watching,
Yeah.
I like it. I really like it.
All right, so let's look at just the front here. Get rid of the fab and the courtyard. All right, so this is the front view, and what I'm showing here is the silk screen and the mask. So if I turn off the mask, this is just the front silk screen. So you can actually see all the things that'll be silked out on the front. And then the mask layer, this is actually voids in the solder mask. So by default, the solder mask is on the whole badge or the whole PCB. So by defining these voids, these will be areas that are exposed that do not have solder mask. So if we're going with like a blue solder mask, these will just be empty space. And then you can see where I've built it around the silk screen, because if you do silk on top of the void, I believe by default in KiCad, that silk is just not going to appear. It's going to automatically remove silk from solder void areas. I think there's a checkbox that you can do when you're building out the Gerber files to not do that and have the silk print on the solder mask void areas. But I didn't change the defaults, so that's why I wanted to make sure the mask did not overlap any of the silk screen. And so these areas on the flames and on the lightning and on the lettering, they actually have similar mask voids on the back side of this PCB. And that is so that the LEDs on the board behind it will shine through them. Now the the solder mask voids on the DeLorean are only on the front because it is basically to expose the copper. So if I show you the copper layer, you can see there's the copper and there's the void. So the void area is just exposing that copper, which is linking to these pins, which will come into the touch sensitive pin on the ESP. So that's kind of how we did that. And then, yeah, if we look at like let me turn on the back mask and turn off the front mask. So you see these are the back side of the board, the solder mask voids there. And they're much larger than what's on the front. That way there's more ability for light to pass through the PCB. I wanted to give it larger void areas. And I didn't have to worry about silk screen on the back. Because if I look at the back silk area, yeah, there's really not much there, and I don't care if the battery's corners get cut off. So that's just kind of outlining where stuff is going to go. So that is that area. Now, what if I'm going to?
I think that's a great feature, by the way.
Yeah, it turned out really good. Another feature that this is the first time I'm using this. This is the mouse bites. So if you look at the way the edge cuts are here, I added this mouse bite footprint. I didn't create the footprint. I downloaded it from I think it's called Panelization Pretty on GitHub, where they have different size mouse bites that you can put in here. And basically you take where the board edge would be solid across there, you cut out a piece of that line and then put in the mouse bite. And then what these are non-plated drill holes. So these are just going to be drill holes in the PCB that are not plated with any kind of metal. That way they'll easily break apart. This is creating like a break line. Same thing over here.
That's cool.
And that way we can easily break these two boards apart, but it's sturdy enough to keep them together until you actually break them apart. And that allowed me to do one PCB instead of two different runs. So I could do it all as one run and then just break them apart. So that was cool. This is the first time I'm using that, so I'm excited to see how that mouse bite turns out and if it works pretty good. Let's talk some of the other features. So one of the things that I tried to do on the silk for the LEDs that had multiple pins was showing you the pin lengths so you know exactly how to put the LED in there. I mean, it was on here as far as like where the slotted side of the LED was, but a lot of people couldn't tell where that was, where you can't easily tell where the pins are. Unfortunately, I was flipping some of these around as I was doing layout, and we ended up with some that are upside down now. So I do need to fix that for the production run. That way they're all facing the same direction, because that's a little OCD thing I have. I just can't stand that. It's going to bother me if I leave that. But for now, that's the way it is. Yeah, and I guess we can jump into some of the actual routing that I did. So let's look at the front copper. Now, front copper on the front board, it's just a solid chunk of copper here going to these wires. These are the header pins. And then down here, that line of header pins comes into the touch pin. Did I need to do all four? No. But I thought when I was drawing this out, this looked kind of cool to have all four lines coming out of it, because when we have this printed, even though this copper is not going to be exposed, underneath the solder mask, you're still going to see the trace bumps, right? It's going to be a little raised area. And so that's going to look kind of like exhaust or something coming off there. So that's why I chose the placement of this and the lines going there to kind of make it look like an exhaust coming out of there, just with the little bump highlights in the solder mask. So I don't know how it's going to turn out, but that was my thought process behind why I use 4 pins on there instead of just one. So then we have our ESP here, and this is our 3-volt output, right? So the 3-volt output is what I'm driving the NeoPixels with. So we can see on this one, 3 volts is coming down here, and I have it coming into this capacitor, and then into the VDD of that NeoPixel. And then it also jumps through here, goes around there, and into this capacitor, which is also connected to this VDD. So that's the first 2 NeoPixels. And then we'll have to look at the back copper to trace the secondary set. So on the back side, we have this 3-volt line coming down here. And same thing, it comes into the capacitor and then feeds the VDD. And then where's the other capacitor? Oh, shit. That's right, I put it on the front because I ran out. Yeah, there it is. So I got to show you both. I was like, where'd that go? And then I just remembered, yeah, because I had to jump over the ground line. So rather than use a via, I just have from this capacitor, we're going on the front copper now across here into this capacitor and then into that VDD. So I'm like, I scared myself for a minute there. I'm like, did I not trace something? All right, so we have that. So that's the 3-volt rail. The ground, let's just walk through that. So the ground is on 2 different pins on the ESP, so I have them both connected here. And it connects to this ground pin for the battery. This is going to be the 2 wires that come off of the 9-volt connector will be soldered into here. So that's the ground wire for that. And then ground comes across here where it hits both of these capacitors and both of the ground pins on the NeoPixels. And then let me get rid of the front for a minute, make it a little easier to see. So then as we trace down here, the ground is also hitting all of these resistors for these LEDs, because the resistor is on the ground side of the LEDs. And so that's grounding all those out. And then on the other side here, you'll see it breaks down here. And then this comes down and it feeds this capacitor here, this resistor for that LED, these resistors, this one and this one for these 2 LEDs, comes across, hits the capacitor for this LED, and then hits that resistor for this LED. So that grounds out all the LEDs using that ground line. Alright, so back to the full view. So that takes care of ground. Now let's talk about the power in. So we have this voltage in can take, I think it says between 3 and 18 volts on this dev board. So we're giving it a 9 volt, but I wanted to switch it. So what I have is the positive from the 9 volt battery is coming into this switch, this 2-position switch. And then one of those positions will feed that 9 volt into the voltage in. And then the other one's just blank, it's a dead pin, so that'll be the off position. So pretty simplistic way of switching it on and off. Now we talked a little bit about power and how the Wi-Fi and using the Wi-Fi will burn through one of these 9 volts very quickly. So we have to keep that in mind, and one of the things we'll probably do for the next run is add another switch, maybe someplace over here or someplace over here, and that switch will wire into one of these input only pins, because that's all we'll need is an input, right? We'll take like 3 volts and put it on that input if it's switched, and that switch will say if it's seeing signal here, we'll have to program it on the code. If it's seeing signal from that switch, I'll turn the Wi-Fi on, but if the switch is off, I'm not seeing signal here, the Wi-Fi will be turned off. That'll give us a nice way to turn the Wi-Fi on and off. That way we're not burning through the battery on the 9-volt battery. One of the other things I was playing with, I don't know how realistic it is, but I found these guys, these little 9-volt shaped batteries that are actually LiPos that have
Oh,
a
wow.
little USB-C connector in the bottom to charge them. And
Oh, that's cool.
yeah, it's got like 1300 milliamp hours, so about um, uh, double what the normal 9-volt has, but it's rechargeable. So you run one down, you can recharge it back up. So yeah, I was playing with that. They're pretty expensive to do for every badge, but might be a nice add-on if I get 30 or 40 of them. We can just sell those as an add-on and just sell them at cost. Say, hey, these cost me $4 a piece or $5 a piece. Give us that, and I'll give
That's
you one
like,
of these, right? What
yeah,
was that?
that's really cool. Actually,
Yeah, I mean, they seem to work pretty well. I've been testing them, so. And there's a lot of different no-name manufacturers, all the different names of manufacturers that I guess are all in China because I can't find any information about any of them. But yeah, the batteries seem pretty okay. They're not as cheaply made as some of the different lipo battery knockoffs I've bought look like. So, but I might end up busting one open just to see what's on the inside, see how badly built it is. You know,
and do they have protection?
it's
Like
supposed
when you're
to. It's supposed to have protection, but like I said, these are just like no name manufactured things. So until I bust one open and actually look at what's on the inside, I won't know for sure what type of protection it has. But it is supposed to have protection from overcharging and over discharging. So yeah, so
on
something to think
EVL,
about.
and there's an NVAL, EVL, Tothel.
Yeah,
That's cool. They're pretty neat, though. I'm
yeah,
glad you shared that.
yeah. So something to play with. It might work out, might not. And I guess that brings us to the conversation of why the 9-volt, right? I've been having a lot of people ask me why the 9-volt. And honestly, I just thought it would be cool to do a 9-volt battery on a badge. I have not seen a badge yet made with a 9-volt battery. Maybe there's one out there that I'm not aware of, but I have yet to see someone's badge use a 9-volt battery, and it's probably because of all the problems that we're running into with it's not going to have enough power. If it drops down below half, might not be able to turn off and back on the badge. It'll get into a boot loop. There's all kinds of potential issues with the 9-volt. But how cool would it be to have a 9-volt battery badge with that being a unique factor, right? Nobody else has that. And and I wanted to play with the rubber band hook method of securing it. That was the other thing that I had this in my head, and I just wanted to see if it would play out. Where on the edge cuts here, you'll see I built in these little hooks, right, on both sides, and I distanced it out perfectly to where if you had a number 8 sized rubber band that would go from like here to here, it would stretch out to go over the hooks here and here. And then what you would have is the front PCB has the 9-volt against it through the hole of the back PCB with the rubber band holding it against the front. So I think that was a cool idea. I just want to see, maybe it's crap, maybe it'll turn out cool, but I just thought having a rubber band holding in place was a nifty trick to play with. So we'll see if that works out. I did buy a bunch of rubber bands for the production, so we'll be able to provide the rubber bands for this. And apparently, they don't tell you how many rubber bands come in a bag. You buy them by the pound. So I probably have 1,000 more rubber bands than I need. But yeah, so that's why we went 9-volt. So yeah, let's go back to looking at the layout real quick. Some of the other things that are laid out here are the data lines for the NeoPixels. Those are Neo 1 and Neo 2. We'll work through Neo 2 first because it's the top one. So this one comes through here and then goes through this big block. And you can see where it's coming into this resistor. And then that resistor is feeding the data in here. And then data out is jumping into this resistor for this other NeoPixels data in. And I probably didn't need this resistor here with only 2 LEDs, 2 NeoPixels in the chain. But yeah, consistency, it looked nice. And yeah, I don't know. If I redo this, maybe I'll end up removing this other resistor because it's really not needed. It's just an extra component at this point. And then I do the same thing with Neo 1.
Wasn't that for the when you're pairing them?
Well, this is for the data line on the NeoPixel,
Yeah.
right? So the very first one in the chain might need a resistor. Even that, because we're dealing with a dev board, it's probably fairly clean signal coming off of there. But this is to make sure that the signal is nice coming into this guy. Well,
Yeah.
coming out of here, we probably, because this is a longer run. That's why I'm saying if you look at this trace, right, there might be some electromagnetic interference there, longer trace. So you throw a resistor on there. This one here is such a short trace. I don't think we need this resistor here. We could probably just come right into the data in line. But
you know what's funny? When I looked at the spec, I actually have R21. I don't have R20.
You don't have R20? Oh.
No. I kept R21 because the spec called for it, but I didn't see R20 on there.
R20.
Well, the spec for the NeoPixels.
Oh, you're saying the NeoPixel didn't call for the resistor. Gotcha. Yeah.
Yeah, like it does call it between them for some reason. And it's a different value. I don't remember what the value was, but
Yeah, let me
I didn't catch that until you just pointed that out.
Yeah, I thought it wanted it on all the data lines. Let me take a look if I can find my reference module for that. Let's see, LEDs.
I actually have one. I'm gonna see if I can do a push.
Well, I
So
have
that downloaded the PDF.
I have reference parts as a separate GitHub
That's right.
repo, and under LED I have these guys. So yeah, this is the one. Look at the PDF for that. Get it the English version.
Yeah, I have this one too.
There we go. So see, resistor data in, resistor data in.
All right, I totally missed one.
Yeah, it's the first one on the top there.
Yeah,
And then they do
I only
the
have the
dot,
one
dot,
between.
dot.
I have the one between the data lines. I don't have the other one.
Yeah, so
That's funny.
it's right there.
Well, it's working.
Yeah, I mean, all that's really there for is to make sure it's getting a nice clean signal into the data in. So, not going to kill anything not having it there unless you had really long lines that had a lot of noise on them.
That's cool.
Yep. So we have that, and then for the Neo 1, we do the same thing. It's run down here. And so that comes into R10, drives that data in. This data out goes to R11, and then that runs across here to that data in. And it's kind of covered by the front copper there. There it is. So if you zoom in, you can actually see what net this is. This is from the D11 to the pad to pad 4. So that takes care of those, and then what we have along this side here is where all of the dual color LEDs are. So we have a separate pin for each color, and that's why we have the different LED AB, AB. So you have 31 AB, 32 AB, 33 AB, 34 AB. And then that's where I had to get kind of creative with where I placed the LEDs. That's why like the 31, 32, 33, and 34 are all in line, but a couple of them are upside down, where this one's right side up. It was all about how I could get these front copper lines to connect without crossing the front copper, because I didn't want to have to do a via just to jump under it, right? So this allowed me to, by putting like 31, 32, keeping it in the order that they are from top down, I was able to run those lines and then connect them in, but I had to like flip these guys upside down to make that happen. And then over here, this guy was right side up because they're coming in from this side. And the reason I came in from this side, from the bottom side, was because I didn't want to get too close to this cutout with the copper, because that's where they're going to be doing drills, right? So I didn't want to get too close to there to come over the top.
So do you see that happen? Have you seen that happen before when you designed it a certain way and they ended up cutting over it?
Yeah, so if you remember my Godzilla versus Blade Runner badge, that badge I actually had the hole for the lanyard was very close to one of the copper lines, and on some of the runs that copper line got cut. I think it was the lanyard hole. It was one of the holes on it. Cut a copper line because I had it too close to the thing, but it wasn't on every PCB. It was only like a dozen or two that got impacted out of the hundreds we ran. But ever since then, I've been very careful about staying clear of these drill cuts, because if they have any, like, because there's plus or minus in their tools, and if it goes beyond their specs, which can happen, it might cut in if I was to run too close to that. And they do have minimum specs listed where you can only get so close to the edge, or to the edge of a cut, or to the edge of the board. But yeah, I just give it a wide berth. So
Yeah.
all right, so we talked
good
about
advice.
all of those pins, and we talked about the NeoPixel pins here, but now we have LED 1, 2 down here, and then we have 3 is here, then 4, 5, and 6. These are for the 6 regular LEDs over here on this side. So these are running from one side of the board all the way to the other side of the board. And so once again, I had to do LED placement kind of carefully. That way I could just run all of these. So you see there's 1, 2, 3, 4, 5, 6 there. No, that's not right. 1, 2, 3, 4, 5, 6, and then the NeoPixels in the middle. But I'm making sure I don't cross any of these lines, and I'm keeping minimum distance between them as I run them all across to come down here. And you can see where I have like D1 and D4 and D2 and D3. The reason that these are placed in the way that they are, these are all blue here. I could have placed them in any order, but this was the order that allowed me to run these traces without crossing any lines. So that was an important layout thing. And when you're laying out the components, keeping in mind how the traces are going to go is one of those important things to keep in mind. That way you can minimize crossing lines, because if you cross a line, what that means is I have to put a via here, then jump a small piece of copper on the back side of the board, put another via for it to come back to the front side. And so yeah, it could get quickly ugly if you're not careful. So routing it, just making sure that you're minimizing having to cross through layers of the board is important.
Yeah, no, it looks great.
Yep. And I think that's all the pins. So yeah, we talked about all of them. And then we have the back silk. I think we looked at a little bit. Let me turn off these
Yeah, I
copper
like that too.
layers. Yeah, so the back silk, pretty simple on this badge because that back silk is going to be hidden inside the sandwich, right? But this back silk here is going to be what you actually see on the back of the second PCB on the back of the badge. And so that's where I have my logo there, the 3000 Society, B-Sides DFW, DC214, Hack Fort Worth, Dallas Hackers Association. We might add some more text or graphics in around this stuff. For right now, I just put the website for the badge, which is not stood up yet. That will go live when the GitHub goes public, because you can't have a URL that's unique like this. And I know it's hard to see it when it's mirrored text, but you can't have a URL that is unique on GitHub on a private repo. They only allow that on public repos. So when it goes public, then I can give it my unique URL to access it, because I always do the badge websites are just the docs directory in the repo that has the EDA and the code and everything else. So it's all one-stop shopping. That one site is the website and all the repo stuff. Makes it easy to maintain it that way. But yeah, that is where we're at with that. So any questions from badge team? I don't know if anyone else joined the call. Doesn't look like it.
I was just gonna comment. This is just to share. I remember you introducing me to KiCad, and I was using FritzSing
Oh yeah, yep.
at the time, and I have to admit, this is so much better than FritzSing.
Yeah, I mean,
Like,
my very
yeah.
first badge that I did, the beer bottle badge, I used Fritzing for that. And it was so simple. Yeah, Fritzing was a decent tool to use for that. But I didn't know any better. I had not used any EDA software before because that was my first badge. So I had used Fritzing before because I used it to demo out breadboards. So if I was doing a demonstration on here's how you can do something cool on a breadboard with some components, I would use Fritzing for that because it had that nice breadboard layout, 3D looking thing. But yeah, for actually designing the PCBs, this works so nice because I mean it has so many tools. You got the schematic, which the net file from this will lead into the PCB. That way you have all the components already loaded with the footprints that you just move around. That's very convenient. And you can maintain your own symbols for the schematic as well as your own footprints. I maintain all of my own 3D models, so every project that I do, I try to keep everything I'm using local, and then I just kind of copy that local library over so that I have, like, in my 3D models here, you'll see there's a lot of components that we're not using on this badge, but this is just kind of my 3D model directory that gets moved into every one of my projects. And then anything that is unique for this project also ends up here. So in our case, I think what you'll see, get to the E's, there's the 3D model for the ESP. So I copy it here. That way when someone does a git pull, they get the whole thing with every component that they need. Same thing with the footprints. I have local footprint libraries, and the local footprint libraries have all of the footprints that I use, like for my logos or for the different components, anything that's needed. And you can see right here, here's all the unique ones for this badge. This is all of the footprints that were based on the artwork that we output from Adobe Illustrator. But yeah, I keep them all as local libraries, and then local libraries for the schematic files as well. Just makes it easy to know that I can pull this project up at any point in the future and it's going to have all the files that were used to create this. That way it doesn't matter if I've upgraded to KiCad 7, and in 7 they've renamed a bunch of stuff that it was named this in 6 and now it's this in 7, and now it doesn't have a reference to it anymore. I ran into that early on with KiCad 4 to 5, and yeah, I was like, yeah, I'm not going to do that again. Just make sure all the files are there, and then it'll convert them to the new version, but you maintain those local files. But yeah, I love KiCad. It works great for what we're doing.
Yeah, it's pretty sweet.
Yep. Yeah, and if you
I don't have
didn't
any
want
questions
to,
though.
yeah, if you didn't want to do, you know how I was doing the export from Adobe Illustrator and then importing it as DXF files in the footprint editor. If you didn't want to do that, if you just had a simple graphic like a logo or something, they even have an image converter. It'll let you load any graphic you want, and it'll produce a footprint from it. And so that's a handy tool too. So,
That's cool.
yep, cool. So, oh, I did have a question for you, Sapien. So, have you put your code up into the GitHub yet? Because I didn't think I
No,
saw
I
it.
need to I need to do a push. I haven't tried it yet.
Okay. Well, because I have the main branch locked to where you have to do a pull request. What you could probably do is just create your own feature branch and leave it in there for now. So,
Yeah.
yeah, just create your own feature branch off of main. You can put the code in there, and then I can see the code without it being in main. And then when it's ready, we can move it over. So, cool.
Yeah. What I also did, you know how you have the numbering there
Yeah.
where it's tester one. For my stuff, I just added a one, so it would be like if I was doing the first one, 101, mine it would be one. It would be 11 basically.
Oh, okay.
Because on some of these, what I wanted to do, since I was duplicating
Mm-hmm.
the effort out, and in my case, I did actually change a couple.
Yep.
Actually, the ones that I changed, I think it was 06 and 07. So it really wasn't the ones before that. It was
Right.
just the last two. Because what I am using is the onboard LED. I'm using that to show the Wi-Fi status.
Oh, okay. That's
Um,
cool.
yeah, so that's actually what I did on basically in my case 16 and 17.
Cool.
So yeah, you'd see them come in that way. I don't know if the nomenclature's all that awesome, but that's what I did.
Yeah, it works for now. This is just our test code. We'll figure out what we're going to name the different codes for if we have different code bases later. But for now, test works. Different tests and explaining what the test is doing. So, yeah, just get your code up into GitHub. That way I can take a look because I'm curious to look at it. And it doesn't have to go into main. It can just be in your feature branch, and I can look at it from there. Cool.
Yeah, I'll create one tonight.
Awesome. All right. Well, I didn't have any other questions for you. Does look like we have a couple of viewers on the live stream. And I am looking at the chat now. So anyone on the live stream have any questions for the badge team before we sign off for the evening? I'm going to take silence as a no. All right. Well, I think with that, this was a very good session. I guess we'll end on the note of if you're interested in getting one of these, definitely check out the Indiegogo campaign. It'll be up for a while now. I think we set it for 30 days, and it's been running for 3 days, so there's like 27 days left. But yeah, definitely check it out. There's the link. And other than that, we will plan on having another design session live streamed next Thursday, a week from tonight. And hopefully we will have the actual development prototype boards in hand and can show them off on the next live stream for everyone. So with that, I am going to sign us off. This is Alt Beer saying thank you for joining the stream, and thank you to the badge team for helping make this a reality. And we'll talk to you all next week. Thanks all.